start this video off, which is going to be about function operations, I suggest you pause and just copy down what we have on the screen right now. Okay, so now that you have this copied down, just want to go through what this notation means. So if we want to say add two functions together, we could say f of x plus g of x. There's also another way of saying it. It makes a new function now. We'll call it the f plus g of x function. And the same thing happens if we're going to subtract or multiply or divide. So I just wanted to do an example that uses f of x and g of x over here. So notice we have g divided by f. So I'm going to write that down. Let's see. That would be x plus 1 over x squared minus 1. And usually we like to simplify that. So notice that x squared minus 1 factors to x minus 1, x plus 1. And then the x plus 1's would cross out, and we'd be left with 1 over x minus 1. Now, something that you need to make sure that you do is to write down the domain if it's restricted. And here's what I mean. When you look at the resulting function, this g divided by f of x function, you should be able to tell that 1 is not a part of its domain. But what's not obvious is that negative 1 is also not a part of its domain, because from up here, notice that we crossed out x plus 1. Look at its factored form before it was simplified. X plus 1 was in the denominator, which means that x cannot be negative 1, or else it would have been 0 up here. That might seem a little weird, because if I were to just look at this final answer, I would just say, oh, no, just only 1. Only 1 makes that denominator 0. But note, we have to go with the actual operation that was done. So we're not looking at the resulting function, we're looking at kind of the whole path that it's taken. So I'm going to say that its domain is negative infinity to negative 1, right, not including it, negative 1 to 1, not including it, and then 1 to infinity.